Let's look at proposition number 21 of book 8 of Euclid's Elements. The proposition says if two mean proportional numbers fall between two numbers, then the numbers are similar solid numbers. So let's say given numbers A and B, there are two mean proportional numbers C and D between A and B. Based on our previous propositions, take E, F, G, the least numbers in the ratio A, C, D. We know how to do that. So since they are the least numbers, E and G are relatively prime. So we have one mean proportional between E and G. So they are similar plane numbers. Again, the previous proposition itself. Okay, let H and K be the sides of E and let L, M be the sides of G. That means E, F, G are in continuous proportion in the ratio H is to L and K is to M. And E, F, G are the least in the ratio A, C, D. And the multitudes are same. There are three numbers here, three numbers here. So that means EFG is equal to ACD. X equally we can say E is to G is equal to A is to D. E and G are relatively prime. That means they are the least in the ratio and they measure numbers in the same ratio, same number of times. Now, let as many units in N as there are E's in A. So which means A is equal to N times E. But E is equal to H times K. E is equal to H times K. Therefore, A is equal to H times K times N, which means A is a solid number because it's a product of three numbers. And H, K, N are the sides. Okay, so we have shown that A is a solid number. Similarly, we have to show that B is also a solid number. So let's start. Again, E, F, G are the least numbers in the ratio C, D, B. And multitudes are same. Means E is to G is equal to C is to B. Actually, we should have written X equally E is to G is equal to C is to B. Now, let as many units in O as there are E's in C. G measures B based on the units in O. That means B is equal to G times O, but G is equal to L times M, since LM are the sides of G. So G is equal to L times M. So which means we can write B is equal to, instead of G, we can write it as L times M times O. So which means B is also a solid number with sides L, M and O. So we have shown both A and B are solid numbers. That means they are products of three numbers. Now N measures A. N measures A HK times. HK is E. So N measures A E times. O measures C. O measures C E times. So which means we can write it as N is to O is equal to A is to C is equal to E is to F. N is to O is equal to A is to C is equal to E is to F. Here E is to F also appeared because EFG is equal to ACD. That means E is to F is equal to A is to C. But E is to F is equal to H is to L is equal to K is to F. Since E, F, G are in continuous proportion in the ratio H is to L and K is to M. So H is to L is equal to K is to M is equal to N is to O. Why? Because E is to F is there here and here as well. So what does this mean? If you look at this, H, K and N, H, K and N are the sides of A. L, M, O are the sides of B. So which means since corresponding sides are in the same ratio, A and B are similar solid numbers. So we have shown that given two numbers, if two mean proportionals fall between them, then the numbers A and B are similar solid numbers. So that is proposition number 21 of book 8 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.